Okay, so this video will be on the practice questions that you did on your first go of practice questions, and it's a compacted maths program for the algebra topic. Okay, so question 1 is asking me to expand the following and then simplify where possible. So I'll start off with A. I've got 4, and in my brackets 3x take 1, take 3, multiplied by 2, take 5x. So to solve this one, I just have to expand both sets of brackets. So the term out the front is going to have to be multiplied, the terms in the bracket are going to have to be multiplied by the term out the front of the brackets. So for the first one, it's going to be 4 times 3x, which is going to give me 12x. Take 4 times 1, which is 4. Now this second bracket, because I'm taking everything away, it's going to kind of change the signs of everything because I'm taking away everything after that takeaway. So you can kind of treat it like a -3 when you're timesing the numbers. That's the way it works best for me. Or you can kind of just swap the symbols around, whichever works for you. So I'm going to take it like kind of like a -3 times 2, which is going to be -6, and -3 times -5x is going to be 15x. Okay, so from there I can collect my like terms. So 12x and 15x are like terms. So 12x plus 15x is going to give me 27x. Take 4, take 6. Well, I can add take 4 and take 6 together. So -4 take another 6 is going to be -10. So my answer is 27x take 10. Okay. So for B, I've got 3x take 1. 3x plus 4. Okay, so this one's a little bit more tricky. So to do this, I have to do a binomial expansion first. So I'll deal with the brackets. So I'm going to expand my brackets like that, do my binomial expansion. So I'm going to multiply, sorry, I'm just going to clear this a bit. Oh no, I didn't need that. Never mind. Okay, so in my first lot, I'm going to do the x, and it's going to be multiplied by the second set of brackets. So it's going to be 3x plus 4, and then take 1, it's going to be 3x plus 4 as well, and my big brackets. And from there, I can just expand my brackets like I normally would. So 3x times x is going to be 3x squared, plus 4 times x is 4x. Again, I've got a take, so it's going to kind of change the signs of everything following it. So it's kind of like a -1 times 3x, which is going to be -3x, and -1 times 4 is going to be -4. So that's my answer there. I can simplify that because I've got a few like terms. So my 3x squared is by itself, there's no like term, but my 4x and my 3x are like terms. So 4x take 3x is going to leave me with 1x, and take 4. So I can't do anything further because x squared and x aren't like terms, because even though they're the same variable, they're not to the same power, so they're not like terms. And then from there, I can just expand my brackets. So everything inside the brackets, we have to be multiplied by that 3. So 3x squared times 3 is just going to give me 9x squared. X times 3 is going to be 3x, and the take 4 multiplied by 3 is going to be take 12. And that would be your answer there. Can't simplify that any further, so just leave that answer as it is. Okay. So move on to C. So C is a perfect square. I've got 3x take 2 squared. So if I was to write that out, I've got 3x take 2 multiplied by 3x take 2. So I just have to multiply all my terms in the first bracket by all my terms in my second bracket. So I've got 3x multiplied by 3x take 2, and take 2 multiplied by 3x take 2. So from there, I can just expand my brackets like I normally would, like so. So 3x times 3x is going to give me 9x squared. Take 2 times 3x is going to be 6x. Again, it's that takeaway, so it's a little bit tricky. So I'm taking away 2 times 3x, which is going to be taking away 6x, and I'm taking away 2 times -2, which is going to give me plus 4 there. So from there, I can simplify because I've got like terms. So 9x squared is by itself. It doesn't have a like term. But take 6x and then take another 6x is like taking away 12x because they're like terms, plus 4. Again, I can't do anything else. No more like terms. So that would be my answer there for C. Okay, so for D, we've got a difference of perfect squares here. So I've got 11x take 4, and then 11x plus 4. Okay, so again, we know how we can do this. It just simplifies to a squared take b squared. So it's just 11x squared take 4 squared. Okay, so 11x squared. So using our power laws, that power of 2 has to go to everything in the brackets. So 11 to the power of 2 is 121, because 11 times 11 is 121. And x to the power of 2 is just x to the power of 2. Take 4 to the power of 2 is 16. So that would be my answer there for the difference of perfect squares. I can't simplify that any further because I don't have any like terms, so I just leave it as is. Okay, question 2, factorize fully the following. So start with a, I've got -5a squared b, take 10ab. So the first step to factorizing is I have to find the highest common factor of both of those terms. So I'm going to look at the numbers first. The highest common factor between the 5 and the 10 is obviously going to be 5, and I'm going to do -5 there because it's a -5 at the start. And a squared b and ab, the highest common factor is they both have the variables a and b, so I'm going to take that out. So then when I'm factorizing, I'm going to write my highest common factor out the front of my brackets. Inside my brackets, I'm just going to rewrite the original expression. And then what I'm going to do is I'm going to divide each of the terms by the highest common factor. So I'm going to divide them both by -5ab. So from there I can cancel. So -5 divided by -5 is going to be 1. B divided by b is going to be 1. And a squared divided by a, it's just going to leave me with 1a. On this side, my b's can cancel, my a's can cancel. If I divide both 10 and -5 by 5, I'm going to be left with -2 up the top. So that's going to leave with -5ab, and then on this side, a take 2. A take -2. And if I simplify that, that's -5ab, a plus 2, and that would be my solution there. Okay, so for b, I still have to factorize. So I've got x multiplied by 2x plus 1, take 2x plus 1, which is all being squared. Okay, so from both of these, I have to once again find the highest common factor, which is the thing they both have in common. So hopefully just looking at this straight away, you can see the highest common factor is going to be 2x plus 1. So if I actually put a 2 in, that will be very helpful. Okay, so it's 2x plus 1 because they both have 2x plus 1. Each of those terms can be divided by 2x plus 1. So I'm going to put my highest common factor out the front of my expression, and then in brackets I'm going to rewrite everything. So I've got x, 2x plus 1 on this side, and 2x plus 1 being squared on the other side. And I'm going to divide each of those terms there by 2x plus 1. So divide that one there by 2x plus 1 as well. Okay, so from here, actually this should be in brackets, there we go. Okay, so from here I can simplify. So 2x plus 1 divided by 2x plus 1 is just going to be 1, so they can simplify and cancel out. 2x plus 1 divided by 2x plus 1 will cancel out, but this was squared, so I'm only going to be cancelling out one of those because there was 2, because it was 2x plus 1 in brackets multiplied by another 2x plus 1, and if I'm dividing by 2x plus 1, only one of those will cancel, so I've still got one lot of 2x plus 1 left. So if I write out my simplified version now, on the left I'm only left with x, and on the other side I'm left with 2x plus 1. Okay. So I can then solve a little bit further. So this bracket's just going to stay the same with my highest common factor, x. But this 2x plus 1, I can actually simplify a bit because I'm going to be taking 2x, take 1, because I'm taking everything in the brackets. So that's why the 1 has changed to a -1, because it's being taken away. And from there, I can simplify it again, so I'm left with 2x plus 1. So x take 2x is going to leave me with a -x, take 1. So that would be my solution there. So I've just removed my highest common factor there and simplified the brackets as I've gone along. Okay, so question 3, we had to solve for x. So for a, I've got 8x equals 2x plus 24. So I've got variables on both sides of my equation, and obviously I don't want that, so I'm going to get rid of the variable on one side. So I'm going to take that 2x from both sides. So 8x take 2x is just going to leave me with 6x. 2x take 2x is going to be 0, and then plus 24, so it's just 24 on this side. Now, I need to get rid of that 6, so if I divide both sides by 6, So 6 divided by 6 is 1, so it's just going to leave me with x, and 24 divided by 6 is going to give me 4. So therefore my x is equal to 4. So that's my solution for A. Okay, so for B, I've got 3 take 4x equals 7x take 8. So again, I've got variables on both sides of the equation, and I don't want that. So it's up to you which one you move. As usual, I'm going to move that take 4x because it's the smaller one, and I don't like working with negatives if I can avoid it, but you can do it either way and it's fine. So we're taking away this 4x because it's got that take in front of it, so the opposite of that is going to be adding 4x. So if I add 4x to both sides, it will cancel out on the left, so I've just got 3. 7x plus 4x is going to give me 11x, take 8. And then I can just add 8 to both sides to get rid of that, so I've got the x's by themselves. 3 plus 8 is going to give me 11. So 11 equals 11x. And then if I divide both sides by 11, I can find out what x is equal to. So x is then equal to 1. So I've just switched it around just because it's convention to write x on the left. So write whatever your variable is, even if it's y or z or whatever it is. Okay, the last one I've got here, C, is 1 take 2, 2 take x equals 5, x take 3. Okay, so to do this one, the first thing you're going to have to do is you're going to have to expand your bracket. So we're getting a little bit of a crossover in our skills here. So it's going to be 1 take 2 times 2 is 4. And because we're taking everything behind that bracket, this is going to turn into a plus 2x. 5 times x is 5x. 5 times 3 is 15. So let's take 15. So then I can just kind of solve this like normal. Oh, wait, no. 1 take 4, I can actually do that one. So 1 take 4 is negative 3 plus 2x equals 5x take 15. So it's probably a good idea to simplify first, just to make it a little bit easier when you're dealing with it. So again, when you're solving these, you can remove the variable from either side, whichever is easier for you. Personally, I'm always going to remove the smaller one. So I'm going to not divide, I'm going to take. So I'm going to get rid of the 2x on the left, and the way to do that is take 2x from both sides. So I'm left with negative 3 equals 5x take 2x is 3x, 3x take 15. The next thing I'm going to do is get rid of that take 15, and the opposite of taking 15 is adding 15, so I'm going to add 15 to both sides. So negative 3 plus 15 is just going to equal 12, so 12 equals 3x. And then I want to get rid of that 3, so if I divide both sides by 3, my x is going to equal 4, and that's my solution there. Okay. Oh, so we are now onto the maps questions. So these ones are a little bit more difficult, but you just need to take your time to try different problem-solving strategies. Just have a go, write down what you know. Often if you write down what the question tells you, you can start to see a way to solve the question. So Gabby is twice as old as Kate, and Kate is 3 years older than Joe. Brett is 4 times as old as Joe. If the sum of the ages of Kate and Brett is 63, find how old each person is. So if you're reading that, that's really confusing. So I'm just going to write down some of the things I know. So for a start, I'm going to assign a variable for each of their ages. So I'm going to let Gabby's age equals a G because it's Gabby, but you can pick whatever you want. So Kate's age, I'm going to let that be a K because I'm very creative like that. Brett's age is going to be, yep, you guessed it, a B, and lucky last, Joe's age is going to be a J. Okay, so what do I know from this question? Well, it tells me that Gabby is twice as old as Kate. So Gabby equals 2 times Kate's age. Okay, what else do I know? Kate is 3 years older than Joe. So Kate's age equals Joe's age plus 3. And Brett is 4 times as old as Joe. Okay, so Brett equals 4 times Joe's age. So that's what I know. So then it goes on to say, if the sum of the ages of Kate and Brett equals 63, find out how old each person is. Okay, so I'm just going to draw a line here, but you would keep working down the page. So, you know, this little box that I'm drawing would be below everything I just wrote. This is terrible setting out. Do not copy this. So, if the sum of the ages of Kate and Brett is 63. So that means if I add Kate and Brett's ages together, I've got to equal 63 because sum means addition. Okay, so if I look back here for Kate, which is here, and Brett, which is here, they both actually have the same variable because Kate was Joe plus 3 and Brett was 4J. So if I just substitute those values in, I no longer have two different variables, I'll only have the same. So Kate's age was Joe plus 3, and if we add Kate's age plus Joe's age, which is 4J, I'm going to get 63. Okay, so you can see I can now actually start to solve this. So I've got some like terms which I can add together, j plus 4j, so I can add those together and get 5j. So as a result, 5j plus 3 is going to equal 63. And now all I have to do is solve for j, and I will know Joe's age. So to solve for j, the first thing I'm going to do is get rid of that 3. So take 3 from both sides. So 5j equals 60. And then if I divide by 5, I'll know how old Joe is. That's 12. Okay. So from there, I know how old Joe is. And if I look back to my original formulas here for everyone's age, I can actually work them out using this. So I'm going to have to clear the screen because I've run out of space, but just imagine I'm still working down the page. Okay, so Joe, how old? So 12. Okay, so then we know that Brett's age was 4 times Joe's age. So that's 4 times 12, which is 48. 48, there we go. We know that Kate's age, what was she? Kate is 3 years older than Joe. So it was Joe plus 3. So 12 plus 3 equals 15. And our lucky last one, Gabby, what was Gabby? Twice as old as Kate. She's 2 times Kate, and Kate was 15, so it's 2 times 15. I've run out of space, so I'm going to write beside, you would write below. Therefore, she's 30. Now, this is a maths question. It's a worded question, so we're going to write a worded answer. So therefore, Joe is 12, Brett is 48, Kate is 15, and Gabby was 30. Gabby is 30. There we go. So you can see if you break it down and start to write down what you know from the question, it's actually a lot more simple than what it initially comes across as when you read it. Okay, question 5. So I've just broken question 5 up so it goes over 2 slides because it's a lot of working. So a triple chocolate brownie is baked in a tray, 3p plus 2 centimeters long and 2p take 1 centimeters wide. A slice the full width of the tray and r plus 2 long is taken from the brownie. So the first thing you have to do is determine the area of the brownie before the slice was removed in factorized form. So if you have a question like this, straight away draw a picture. So I'm going to draw this brownie. Here's my brownie. Ooh, just turn that straight. So I know that the length here is going to be 3p plus 2. So that's how long my brownie tray is, and the width was 2p take 1. Okay, there we go. So for A, I have to determine determine the area of the brownie before the slice was moved. So area equals length times width. So my value for length is 3p plus 2, and my width there is 2p take 1. Done. Because it says in factorized form, so I don't have to actually solve that. I can just leave it as is. So I've just multiplied the length times the width. There we go. That's the area of my brownie before a slice was taken. Okay, so I'm just going to clear this. I'm going to have to redraw my picture, but I've just run out of space to answer. Actually, no, I won't. I'll be able to fit B here. So for B, determine the area of the slice taken from the brownie in factorized form. So it says a slice, the full width of the tray. So my width is here. It's 2p take 1, so it's the full width. So I cut a generous slice all the way down. And the length is r plus 2. So across here, it's r plus 2. So to work out the area of my brownie, I'm going to have to do, again, length times width. So it says that the length here is r plus 2 long. So I'm going to substitute that into my formula, r plus 2. And my width, well, it says it's the full width of the tray up here in the question, the full width of the tray. So I know what my width is, so I can just write that in, 2p take 1. So there you go. That's my answer. The area of my brownie slice would be r plus 2. multiplied by 2p take 1. It says to answer in factorized form, so I don't have to solve that. I can just leave it as is, and that's my answer. Okay, so C, use your answer to parts A and B to find the area remaining after the slice was removed. Write your answer in the simplest factorized form. Okay, so this is where it gets a little bit more complex. So the area that's going to be left behind is going to be the area of the tray minus the area of the brownie slice. So I'll just do that. So I know my area of the tray from my previous question. It's written in A. What was it? 3p plus 2 and 2p take 1. So that's my area of my tray, and I have to take away the area of the slice, which I know from B, which was 2p take 1 multiplied by r plus 2. There we go. So it wants me to answer in my factorized form. So what I'm going to do is I'm actually going to look at my factors, my highest common factor between the area of the tray and the area of the slice. So if I look at those as wholes, I can see that my highest common factor, which I'm going to write over here, is actually going to be 2p take 1, because the area of the tray has that and the area of the slice has that, because they both have, what was it, the width? No, the length. Whatever it was, the width, the length, can't remember, in common. So they've both got that 2p take 1. So from here, I can actually just factorize my expression. So I'm going to write that highest common factor out the front. So it's going to be the 2p take 1. And then inside big brackets, I'm going to write that whole expression from the line above and divide each of the parts by my highest common factor. So I've got 3p plus 2, 2p take 1. Dividing all of that by 2p take 1. And then we're going to take away 2p take 1, r plus 2, divide all of that by 2p take 1, close my brackets. Okay, so from there I can probably do, as you can see, I can do some cancelling. So these are going to cancel. Oh, sorry, that should be in brackets. So that's going to cancel. So I'm still going to leave my highest common factor out the front. In my brackets, all I'm left with is, let's go, 3p plus 2 take r plus 2. Okay, so from here I can just solve this a little bit further. So this is going to be 3p plus 2 take r take 2, because I'm taking everything in those brackets there, and then I can solve that. So it's 2p take 1. So 3p, there's no like term, so that's going to stay. Plus 2 and take 2 are like terms. So plus 2 take 2 is just 0, and I'm just left with take r. So there is my solution there. So the factorized answer there would be 2p take 1, 3p take r. So all I've done is I've found the highest common factor from the area of the tray and the highest common factor from the area of the slice, and just solve that to find my answer in factorized form, which is here. Okay, so after you've done all that, D says explain how you could find the area in part C more simply. Okay, so I'm just going to write my worded answer here. So we can see from our drawing, which you should still have on your page, the remaining slice has a width of 2p take 1, because it was the whole width of the tray, and its length, so its whole length was going to be 3p plus 2, but remember we've cut a slice out, so it's still going to be 3p take 2, sorry, 3p plus 2, but we have to take off that little bit that we cut off for the brownie. So we had to take the length of the brownie, which was r plus 2. So now I know my width is 2p take 1, and my length is going to be 3p plus 2 take r plus 2. So we can actually solve from there. Therefore, the area left is actually the length times the width, and the length is 3p plus 2 take r plus 2, and the width is 2p take 1. And I can simplify my length a bit further. So remember, 3p doesn't have any like terms. Plus 2 take 2 is 0, so let's just take r, and this side will be 2p take 1. So that's actually the same answer as we got before, just a much simpler way of getting there. So that's how I could find the answer a little bit more simply without using that factorized form. In a factorized form, but without using the highest common factors. Okay, the last question is create two different expressions, each containing the variable x, such that the product of the two expressions equals 24 when x equals 7. Show that your answer is correct. Okay, so if you're reading that, that probably sounded really confusing and hard, but it's actually not. Again, write down what you know. So there are heaps of solutions to this, like probably infinite solutions. I'm just going to show you one way of doing it. If your answer is different, that's fine. If your expressions are different, that's fine. I'm assuming they are, but you should still get an answer that satisfies this problem. Okay, so we need to have two different expressions. So we need to have expression 1 and expression 2. So I'm going to say let expression 1 equals A and expression 2 equals B, because it says two expressions. So there we go. I'm going to have two different expressions. So A and B are going to be my two different solutions. So it also says the product of the two expressions equals 24. So that means A times B has to equal 24 when x is 7, okay? So I just have to think of two numbers that have to equal 24. So you can pick whatever you want. You can do 12 and 2 and 8 and 3. I'm going to do 6 and 4. So I'm going to let A equals 6 and B equals 4. There we go, because when I multiply them together, they're going to equal 24, because 6 times 4 is 24. So for A, I have to get an expression that's going to equal, what is it going to equal? 6. Okay, so I'm just going to think of any numbers that have got to equal 6, but the only catch is I have to involve x equals 7. So 7 and then whatever I want to add to it, and it has to equal 6. So straight away my brain thinks take 1. Take 1. So 7 take 1 equals 6, x take 1 equals 6 when x equals 7. That kind of makes sense, hopefully. Okay, for my expression B, it has to equal 4. So I have to have something equal 4, but I know that x has to be 7. So 7 and then doing something to the 7, I have to get to 4. Again, my brain's taking the easy way, and the thing I think of is take 3, because that's pretty easy. 7 take 3 is going to equal 4. So x take 3 equals 4 when x equals 7. So it's not enough just to do this. I have to show that my answer is correct. So I'm just going to clear the screen, but you'd keep working down the page. Okay. So I've got to show that A times B equals 24 when x equals 7. So I'm going to show that. So this is because, okay, so A times B equals, so A was, what was it? X take 1. X take 1. And B was x take 3. X equals 7, so I'm going to substitute that in. So 7 take 1 multiplied by 7 take 3. So 7 take 1 is 6, 7 take 3 is 4, and then 6 times 4 equals 24. So I've just proved that that equals what it has to. So again, as I said, you can have all different numbers, all different expressions, but your answer should still have x being equal to 7 and your two expressions when multiplied together being equal to 24. You could solve this by doing a binomial expansion, expanding the brackets. You'd still get to the same answer. It's just going to take you a lot longer. And that's the end of this video of the solutions. I know it's a long one. If you have any questions at all, if I've gone too quickly over some stuff, please come and see me for help if you need to.